The Lorentz force, also known as the electromagnetic force, is created by the combination of electric and magnetic fields. Its uses include devices such as electric motors, railguns, and loudspeakers. This demonstration will resemble that of a railgun. The setup consists of two parallel metal rails connected to an electrical power supply. When a conductive material, in this case a metal rod, is placed so that it touches both rails, it completes the circuit. Electrons will flow from the negative terminal of the power supply up the negative rail, across the conductive rod, and down the positive rail back to the power supply. The current makes the apparatus behave as an electromagnet, creating a magnetic field inside the loop formed by the length of the rails up to the position of the rod. In accordance with the right-hand rule, the magnetic field circulates around each part of the circuit. Since the current is in the opposite direction along each rail, the net magnetic field between the rails is directed at right angles to the plane formed by the circuit. In accordance with the other right-hand rule, when there is a current-carrying wire in a magnetic field, a force is acted on it. In this case, the combination of the current in the rod and the magnetic field created by the current in the circuit produces a force which accelerates the rod along the rails away from the power supply. There are also forces acting on the rails which attempts to push them apart, but since the rails are mounted firmly, they cannot move. This force is called the Lorentz force. The IB textbook gives no name to this force and simply refers to this phenomenon as the motor effect. Watch as the rod, placed on the rails, completes the circuit and starts rolling away from the power supply.